So over the next few sessions we're going to create a new deformer. I call this deformer deform by surface, and the way it works is it just takes an object and it will deform by the surface, and it can be rotated and controlled in several different ways. So you can use it as a kind of volume based squash and stretch, or we're going to use it later on for some other examples. So to get started, the way I started and worked out how to actually create this effect is I looked at some examples. And I went to browse examples and I said what deformers are in here and how can I use these to understand how to build my own custom deformer. So here's a push deformer. This is one of the most simple basic deformers, and the way it works is it has an object and you get the point position and you get the point normal, and you add the point normal and point position together. You can control the amount it's pushing or bulging by multiplying the value. In this case here it has a weight map tied into it. I can remove the weight map and just manually control this multiplier that increases and decreases the amount it pushes. The point normal and point position are added together and then reset back to the point position again, and that's how a push works. You can see it can be simply built in just 5 nodes. A more complicated example would be something like the bidirectional mesh-to-mesh deformation example. This may take a little longer to figure out how it works, but again we can hit play. I'll just turn the grid off, go to shaded mode, it'll just look nicer, and play, and you'll see here it's deforming. In this case both objects are deforming because they both have ice trees on. I'm going to take the ice tree off the ground just by selecting it and deleting the ice tree, and then we can just move this object here up and down and we can see the effect. It's not bulging quite enough. We can actually go into the dent compound, double click, just going to increase the weight here to give it a more full effect, and you can see in this case we've got this similar deformer to the one I had before, and also again it does rotate. So that's a couple of examples of how these different deformers work. If we look inside this dent deformer, we can see it does several different effects. It takes sets some data, it performs a raycast, and in here is a bunch of nodes. We take the raycast node and uses that to actually make sure the points don't go through the ground. It does a collision. It calculates a bulge. This is actually a whole bunch of nodes that does this. Really is looking for the nearest points and calculating the distance between points and then setting some values. We're going to create our bulge in a slightly simpler way than this example. And then it applies the deformations, and it's similar to the push deformer. It takes a point normal and point position and adds them together and then multiplies it by several different values. These values include the raycast value and the push value, or the bulge value. With all this knowledge we can go ahead and start building our own deformer. So we're going to open up our basic scene and start building our own deformer next.